Okay, so first question, do we have any non-Polish speaker on the audience? Yes. Yes? Okay, I'm not lucky. So close. Okay, so we'll be in English. So a little about me. This is my picture 2 weeks ago. I broke a bone, so this is the reason I'm standing like that here on the stage. I have around 14 years experience in IT and 5 years with big data tools. I started mainly in Spark, and then I was going in the DevOps direction because from my perspective, 90% working in big data is a DevOps work because you need to create all the environment and then you can run some stuff on top of it. I'm working in DXC technology starting from last Thursday, so it's quite a new job for me. I will be working in the automotive part, so autonomous cars will be my next project. So this is the big data. I mean, one car can create 2 terabytes of data per hour. If you have 30 cars, it's about petabyte per day. So yeah, this is big data really. And it's only one of the projects in this company. It's quite a big corporate that has offices around the world. Okay, so I will start with the introduction to Kubernetes. We can skip something if you know everything. If not, I want everyone to be on the same page. Then I will tell about Helm, and then I will tell about how to run different big data technologies on top of Kubernetes, like Kafka, HDFS, Spark, Flink. And the last part is live demo. Maybe it will be working. Sometimes it works, sometimes not. Maybe I'm lucky today. So first question, how many of you heard about Kubernetes? Yeah, how many of you use it on production? Okay, so a few people using it on production. How many of you are using big data tools on top of Kubernetes? Anything Spark, Kafka, 1, 2, 3. Okay, so it's not popular. So I will start with a small introduction to Kubernetes, only a few minutes, and then I will move to the big data part. So as you may know, Kubernetes originates from Greek, and its meaning is herdsman or pirate, and K8S is the abbreviation of this word. So it's K, 8 letters, S. And this project was created by Google based on Google internal project Borg. Why Kubernetes? I think right now this question is quite obvious. So you can see that there is a big increase in the number of Kubernetes users, and all of the competitors, I think, are almost dead. Maybe you heard about Mesos. Yeah, some of you have ever used Mesos. Yeah, two people on the honest tree. Nomad, also 3. So yeah, I think that those projects were popular, more popular a few years ago. Right now, Kubernetes is the king. So what about Hadoop? Hadoop was the technology 10 years ago. It was hype for the Hadoop, and right now it's decreasing. Yeah, so you can see, sorry, my pointer is not working correctly. I was trying to fix it. So it's decreasing essentially, and you can see that the Kubernetes is right now more popular. And by Hadoop, I mean whole Hadoop technology like HDFS, etc. And of course, Kubernetes is right now is the most popular project on the GitHub. So I think that I can skip this. Main concepts. So how Kubernetes is working, that it's working. Probably you know Docker and you know containers, yes? All of you. So Kubernetes also have containers, and here on this screen, it's these small boxes here. So in Kubernetes, we are not talking only about containers. but we are connecting containers in something we can call logical host. So if you have virtual machine and you have many different processes on one virtual machine, this is physical host. Here you can have many different. Do we have any different raster pointer or something like that? Because nope, sorry. So it will be like that. So here you can have many different containers connected. Those containers has the same IP address. They can communicate on the local host address between, and they have same storage. So you can create logical host with 3 processes, 3 containers, and for example 2 volumes. And this is pod. So this is the main and basic building block in Kubernetes. Every process you're running on Kubernetes, you're running in pod. But the problem with pod is that you can create pod, and then if you kill pod, you have nothing. Or if the node where pod is running is killed, also pod is killed. So we want to have something more resilient. And for that, we have deployments. It's mechanism wherein you can specify that you want to have some number of pods, some number of replicas, and that's all. And Kubernetes automatically will create the number of replicas. If some pod will die, then Kubernetes will create a new one. And also, there is we can also create auto-scaling rules for the deployments. And for example, if we need more pods, then Kubernetes will automatically scale up deployment or scale down. Of course, we can also do this manual. So we have deployment with 2 pods. Let's think that we need 5. We are just changing one configuration line, and then we will have 5. Then, if we want to communicate between pods, we need some form of communication, and in Kubernetes this is service. So we have load balancing mechanism before pods, and we can use it to communicate between services. And here, every service has separate IP address, so you can connect to this IP address. Then there will be load balancing. There will be load balancing between pods. Also, every service has DNS name in cluster, and this service can load balance to many different pods, even to different deployments. It's what do you need? After that, we can also add the volumes and the storage to our pods. So for example, if you want to run database on top of Kubernetes, we need storage. And we have many providers for this storage. If you are running Kubernetes on the cloud, the storage will be added automatically. If you are on premise, then you need to do this on your own. For example, if you have AWS, you can use Elastic Block Store. Same for Azure, same for Google Cloud. But if you are on premise, probably you need to create your own deployment of CEP file system, and then this will be the storage for our cluster, or you can add some kind of network attached storage to the cluster. Okay, so we have deployments, and deployments was meant mainly for the stateless jobs. But if we want to use stateful applications, like for example Kafka, there is different mechanism for that in Kubernetes, which is called stateful set. And stateful set is a pod with storage. So you can specify that you need some number of replicas, not only of pods, like in deployments, but also some number of replicas of storage. And then stateful set will create this in pairs. So to every pod there will be storage attached. And of course, there is also mechanism for rolling upgrade of this, or scaling up or scaling down. And I will show you this later on the demo. And this is the last thing here, which is daemon set. Sometimes you need to run your application on every node of the cluster. For example, logging, monitoring, or cluster storage. And this is daemon set. So if you create this, then you are sure that on every node of the cluster there will be exactly one replica, one pod of the tool you are running. Sample, jak na przykład example is the Prometheus exporter. So if you want to monitor your cluster using Prometheus, then you will get this. Of course, I never wrote any daemon set deployments on my own. You are just downloading this from the internet and using it. So normally, when you're creating your own, this will be probably deployment, maybe stateful set. I never used daemon set. So, to sum up, first you have pod, and this is for kind of testing purposes. Sometimes you want to just run something on the Kubernetes cluster to test something, then kill it. Then for the stateless application, you have deployments. For stateful application, you have stateful sets. And daemon sets are just used for monitoring, logging, storage, etc. And I think skip, and there will be a movie. I hope you don't know this.
My daughter sidled into my office and asked me, "Dearest father, whose knowledge is incomparable, what is Kubernetes?" Right, that's a little bit of a paraphrase, but you get the idea. And I responded, "Kubernetes is an open source orchestration system for Docker containers. It handles scheduling onto nodes in a compute cluster and actively manages workloads to ensure that their state matches the user's declared intentions. Using the concepts of labels and pods, it groups the containers which make up an application into logical units for easy management and discovery." And my daughter said to me, "Huh?" And so I give you the illustrated children's guide to Kubernetes. Once upon a time, there was an app named Phippy, and she was a simple app. She was written in PHP and had just one page. She lived on a hosting provider, and she shared her environment with scary other apps that she didn't know and didn't care to associate with. She wished she had her own environment, just her and a web server she could call home. An app has an environment that it relies upon to run. For a PHP app, that environment might include a web server, a readable file system, and the PHP engine itself. One day, a kindly whale came along. He suggested that little Phippy might be happier living in a container. And so the app moved, and the container was nice, but it was a little bit like having a fancy living room floating in the middle of the ocean. A container provides an isolated context in which an app, together with its environment, can run. But those isolated containers often need to be managed and connected to the external world. Shared file systems, networking, scheduling, load balancing, and distribution are all challenges. The whale shrugged his shoulders. "Sorry, kid," he said, and disappeared beneath the ocean's surface. But before Phippy could even begin to despair, a captain appeared on the horizon piloting a gigantic ship. The ship was made of dozens of rafts all lashed together, but from the outside, it looked like one giant boat. "Hello there, friend PHP app. My name is Captain Kubi," said the wise old captain. Kubernetes is the Greek word for a ship's captain. We get the words cybernetic and gubernatorial from it. Led by Google, the Kubernetes project focuses on building a robust platform for running thousands of containers in production. "I'm Phippy," said the little app. "Nice to make your acquaintance," said the captain as he slapped a name tag on her. Kubernetes uses labels as name tags to identify things, and it can query based on these labels. Labels are open-ended. You can use them to indicate roles, stability, or other important attributes. Captain Kubi suggested that the app might like to move her container into a pod aboard the ship. Phippy happily moved to Kube's giant boat, and it felt like home. In Kubernetes, a pod represents a runnable unit of work. Usually, you will run a single container inside of a pod, but for cases where a few containers are tightly coupled, you may opt to run more than one container inside of the same pod. Kubernetes takes on the work of connecting your pod to the network and the rest of the Kubernetes ecosystem. Phippy had some unusual interests. She was really into genetics and sheep, and so she asked the captain, what if I want to clone myself on demand any number of times? Well, that's easy, said the captain, and he introduced her to the replication controllers.
This is deployments.
Replication controllers provide a method for managing an arbitrary number of pods. A replication controller contains a pod template, which can be replicated any number of times. Through the replication controller, Kubernetes will manage your pod's lifecycle, including scaling up and down, rolling deployments, and monitoring. For many days and nights, the little app was happy with her pod and happy with her replicas. But only having yourself for company is not all it's cracked up to be, even if it is n copies of yourself. Captain Kubi smiled benevolently. I have just the thing, he said. No sooner had he spoken than a tunnel opened between Phippy's replication controller and the rest of the ship. With a hearty laugh, Captain Kubi said, even when your clones come and go, this tunnel will stay here so you can discover other pods and they can discover you. A service tells the rest of Kubernetes' environment, including other pods and replication controllers, what services your application provides. While pods may come and go, the IP address and ports of your service remain the same, and other applications can find your service through Kubernetes' service discovery. Thanks to the services, Phippy began to explore the rest of the ship. It wasn't long before Phippy met Goldie, and they became the best of friends. One day, Goldie did something extraordinary. She gave Phippy a present. Phippy took one look, and the saddest of sad tears escaped her eyes. Why are you so sad? Asked Goldie. Oh, I love the present, but I have nowhere to put it, sniffled Phippy. But Goldie knew what to do. Why not put it in a volume? A volume represents a location where containers can access and store information. For the application, the volume appears as part of the local file system. But volumes may be backed by local storage, Ceph, Gluster, Elastic Block Storage, and a number of other storage backends. Phippy loved life aboard Captain Kubi's ship, and she enjoyed the company of her new friends. Every replicated pod of Goldie was equally delightful. But as she thought back to her days on the scary hosted provider, she began to wonder if perhaps she could also have a little privacy. Sounds like what you need, said Captain Kubi, is a namespace. A namespace functions as a grouping mechanism inside of Kubernetes. Services, pods, replication controllers, and volumes can easily cooperate within a namespace, but the namespace provides a degree of isolation from the other parts of the cluster. Together with her new friends, Phippy sailed the seas on Captain Kubi's great boat. She had many grand adventures, but most importantly, Phippy had found her home. And so Phippy lived happily ever after. The end.
Okay. So we have our Phippy here, and we have our Kubernetes cluster, and now it's time to install something on top of it. Normally, if you are running something on Kubernetes, you need to write a lot of YAML files. Every pod, deployment, stateful set, volume needs few lines of YAML, and normally when you're running your application with all the components, it can be even thousands of lines. So there is a tool to the rescue of that. I don't know how many heard of Helm here. A lot. Okay, so for those who didn't heard about this tool, this is package manager for Kubernetes. It's like apt or yum for the Red Hat. But here packages are, for example, Elasticsearch or Postgres or Prometheus or many other applications like Vault, Nginx, whatever you want. So you have all the components in one package. You are just running, for example, Helm install MySQL, and you have MySQL up and running with all the volumes, with all the configuration on top of your Kubernetes cluster. And I will show you how to use this Helm package manager to run some big data tools on Kubernetes. So let's start with Kafka. You know Kafka probably. How many of those components you heard about? Probably Kafka server for sure, but have you heard about Zookeeper? Yeah. So this is the tool. If you want to run every component of Kafka, and for example use Avro with Kafka, you need Zookeeper, Kafka server, schema registry, probably sometimes Kafka Connect, maybe Kafka REST. There's a lot of components. And because I'm lazy, I want to use Helm to insert those components. This is the first idea I have. So, first question is which of the type of deployments we can use here. Zookeeper is easy. It's a stateful application, so we want to use stateful set. What about Kafka? Any ideas? Okay, and others? Yeah, all others are stateless because schema registry, Kafka Connect, and other tools are saving the configuration on special topics in Kafka. So we want to use this, and we don't want to create by own stateful set and deployments. So let's try to find Helm charts for those tools. Okay. So the problem is that there's only tools for Zookeeper, Kafka, and schema registry. If you go to the official Helm repository, it's only that. And the idea is that there is Confluent Corporation that it's creating Helm chart for all of the tools. And I will show you on the demo how to run Kafka just with one command line, Helm install Kafka. You will get all of this with the deployment stateful set up and running. And officially it's only preview, but I was using it on production and it was working. Yeah, using development preview on production is a good idea, as you may know. Okay, then of course there is the HDFS, and the problem is that storage and Kubernetes doesn't work well together. And with HDFS, this is still the problem because you have many components. So if you just want to use simple HDFS, you have name node and data node. But if you want to have high available components, then you need Zookeeper, Zookeeper failover controller, journal node. It's a lot of that. Also, you need stateful set or daemon sets, because I told before that daemon set could be good for storage. And it's even more than on Kafka. And there is also official chart for HDFS, but the problem is that it's not support HI, and it's only HDFS with Yarn, which doesn't have sense because Yarn can be easily replaced by Kubernetes. So there is another solution. There's a project called Apache Spark on K8s, and there is Kubernetes HDFS chart. But if Kafka is development preview, this chart for me is early alpha. So from my perspective, it's not a good idea to run HDFS on top of Kubernetes. It's not working. There's a lot of bugs here. If you really need storage on Kubernetes and you need storage provider and you are on premise, then I think trying Ceph will be the better idea. Okay, we have our data, we have Kafka and HDFS. Now we want to process the data. And there are some ideas how to connect the processing engines like Flink and Spark to Kubernetes. The standard idea is something which is called active mode. So we have the tool that knows that there is a Kubernetes inside and can connect to Kubernetes. For example, this is how Spark is working on Kubernetes. So when creating Spark application, we are specifying Kubernetes master, then Spark connect to Kubernetes and create all the pods, driver, executors, and it's working. This is the same like, for example, Flink on Yarn or Mesos. But Flink doesn't support Kubernetes right now. Second idea is reactive mode. So app doesn't know about Kubernetes. App only knows that there is some number of replicas of this application and have mechanisms to communicate. For example, this is how Kafka Stream is working. So we can create, for example, 10 replicas of Kafka streams, and Kafka streams connect to Kafka, do the discovery of all the pods, and it will be working without any knowledge of Kubernetes. Even some of the application can be on bare metal, some of the Kubernetes. If there is a network connectivity, everything will be working. And the last one is standalone mode. So you are creating cluster of your application on Kubernetes. This is the idea how Flink can be deployed on Kubernetes. So creating standalone Flink cluster, and you have Flink on Kubernetes. Easy. But not the best idea, really. So for Spark, this is work in progress. Historically, there was Spark on Kubernetes fork. And I think everything was working on this fork, but it was discontinued 1 year ago. And they're migrating all the changes from this fork to the official Spark version. So in Spark 2.4, which is current, some things are working. Like we have this active mode, so Spark can connect to Kubernetes. We have PySpark and Spark R support. And we have client mode support. So for example, we can use PySpark interactively and everything will be working. But there is no dynamic resource allocation. So we need to specify the number of resources Spark needs, and there is no way to change it during the job running. And this was working on the Yarn and also on this fork. There is no shuffle service. This is the connected with dynamic resource allocation, and there is no data locality with HDFS. So if you have your Spark job on the same server like your HDFS on Kubernetes, Spark doesn't know about that. And everything was working on the Spark on Kubernetes fork. Maybe this will change with the Spark 3.0. I think that a few days ago there was preview version of the Spark 3.0. So I think that maybe next time this presentation will change. About Apache Flink, how many of you is using this tool? Only one person? Okay, so maybe I can skip this. It's not Flink doesn't support Kubernetes. You're just creating standalone cluster of Flink, so nothing interesting here. I was on the Flink forward. This is the Flink conference in Berlin 2 years ago, and there was great presentation about how Flink will support Kubernetes. It was 2 years ago. There is no support still. Okay, and the last idea is something which is called Kubernetes operators. Okay, so what is operator? First, we can create our app on our own. So if we have Kafka, we can create all the stateful services or our own or using Helm chart. But then there are some problems. For example, what to do when we want to decrease number of nodes in Kafka? If we just change the number of replicas in the stateful set, then we will lose some of the data on the last node, and there is no automatic migration of the partition of topics, and then we can have problems. Also, when upscaling, we will create a new node, but there will be no data, no replicas on this node, and no automatic mechanism on Kafka, because Kafka doesn't support Kubernetes and this kind of scaling, upscaling and downscaling. Similar for other databases like Cassandra, Elasticsearch, etc. So, idea is to create mechanisms in Kubernetes that can handle on all the upscaling, backups, etc. And in Kubernetes, it's called operator. It's working like that. We are creating special resource. We can, this is sample, we can call it whatever we want. It's called custom resource definition in Kubernetes. And for example, we want to have resource Kafka. And there will be a tool called operator. Then when this Kafka resources will be created, we'll create Kafka cluster. This tool is called operator. And this operator is trying to observe all the custom resources. Then we'll calculate the difference between current state and desired state. And then we'll act. So create all the stateful set, or do the topic migration, or do the downscaling, or backups, whatever you want. And this is how it's working. So we're creating Kafka cluster, so our custom resource. Then there is operator here that knows that to create Kafka cluster, you need to create stateful set with Kafka. Because we are just creating clusters, so there is no need for additional work. So this operator are using Kubernetes API to create stateful sets. There will be two stateful sets, one for Zookeeper, second one for Kafka. And then Kubernetes normally will create all the pods for the stateful sets. Now it's easy. But what if you want to downsize cluster? Then we are changing our Kafka cluster definition, for example, from 3 to 2. And before updating the stateful set, this operator knows that there is a need to move topics between Kafka nodes. So all the work we need to do manually before destroying one of the pod in stateful set, now it's done automatically. And there is many operators in the Kubernetes world. There is operator for Kafka, for Spark, for TensorFlow, also I think for Cassandra, for Elasticsearch, and you can use it. And also you're using this in layers, so you have operator and you have Helm chart to create operator. So that's the idea how to run this. Questions right now? So I think that I can move to the live demo. I hope this will work. Można tu prosić o pomoc z tym mikrofonem? Muszę go przesunąć. O, tak słychać? Słychać mnie? Dobra. Okej. I have a cluster on AWS with 3 nodes, Kubernetes cluster. Of course. Is that okay? Bigger? Even bigger, okay. There is more seats here in the first row. It could help. I do. Okay, one size bigger. Okay, and I will do 2 things. First, I will create Kafka cluster. And I just need to go to the proper directory. Okay, and I'm using this Confluent chart for the Kafka, and we can see that there will be new pods creating. Okay, so you will see that there is Kafka Connect pod, Kafka REST, schema registry, first of Kafka stateful set and first of Zookeeper stateful set. And of course, we need to wait just a few moments before this will be creating. So in the meantime, I will show you how to run the newest version of Spark with newest version of Kubernetes. And you're running this like this. Okay. Yeah, we are using Spark Submit. Then we are using Kubernetes masters. You need to, before running Spark, you need to create your own Spark image, put it to the Docker repository. Here I'm using Elastic Container Repository on AWS. Of course, there are scripts for that. You need to also configure something. And if you are using the newest version of Spark with the newest version of Kubernetes on AWS, this is the correct error because it's not working. There is a patch for that in Kubernetes in Spark. So probably the next version 2.4.5 will be working, but I was lucky, so I compile Spark on my own with this patch, and now we will calculate the number of P. In the meantime, I hope there will be enough memory on cluster. So you can see right now that Kafka is creating slowly, and there is also Spark, two Spark processes here. First, it was driver. And there was executor just for a moment, and driver completed the job. And here we can see that it will be probably in the driver logs. So in driver logs, you can see that P is only 3.13. You know, this Spark P example is you're just getting random number. I'm checking if it's inside the circle or outside, and that's P is calculated here. But it's working. Yeah, we can of course change the number of how many times you are getting this random number. Then probably P will be better. Maybe even 3.14. Yeah, and meantime, yeah, Kafka is starting slowly. I think everything is running. And the last thing you can run here, yeah, Kafka is running. And the last thing you can run is HDFS. And then no, Kafka is not running. Normally, after few restarts, Kafka will be starting properly. Yeah, it's, you know, first rule of the demo. Demo gods are not pleased today, probably. But you can see that also all the components for Zookeeper are creating. So we have Zookeeper for HDFS. So we have Zookeeper name node, data node, journal node, and also after a few minutes, probably this will start. And in the meantime, if you have any question, then I think this is good time for that. So any questions?